Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. The circle inscribed within triangle ABC touches sides AB and AC at points D and E respectively. P is a point on the circumference such that straight lines PD and PE meet BC extended in either direction at Q and R respectively. If angle BDQ equal to 43 degrees and angle CER equal to 36 degrees, we have to find the value of angle QPR in degrees. And this is not a multiple choice question where we can potentially make a smart guess out of the choices given. All we are given is a box or a blank that we have to fill in. And in this case, the value that we have been asked to find is that of angle QPR in degrees. So let's start this problem by considering the center of this circle. Let's call that O, and let's join OD and OE, the two radii of the circle. Now AB and AC being tangents to the circle, that makes the radii OD and OE perpendicular to AB and AC respectively. So that means essentially that angle ADO and angle AEO are 90 degrees each. Now let's consider what's the value of angle ADP, which is marked in blue. It's actually very simple because angle ADP and angle BDQ are vertically opposite angles formed by the intersecting lines PQ and AB. And we know from a fundamental theorem in plane geometry that vertically opposite angles formed by two intersecting lines should be equal. So that makes angle ADP equal to 43 degrees. And we can basically apply the same logic to angle AEP. So that's the angle marked in green. And angle AEP and angle CER, these are also vertically opposite angles and they should be equal as well. So we can write angle AEP, that's the angle marked in green, as equal to 36 degrees. Next, consider what will be the value of angle PDO. So that's the angle that's marked in purple. Now, angle ADO as a whole should be 90 degrees because OD is perpendicular to AB, right? So that makes angle ADO equal to 90 degrees. And a part of that angle is angle ADP, which we know is 43 degrees. And angle ADP and angle PDO, so that's the angle marked in purple, they should add up to make the whole angle ADO, which is 90 degrees. So angle ADP plus angle PDO must be equal to 90 degrees. But we already know what angle ADP is, which is 43. So that makes angle PDO equal to 90 degrees minus 43 degrees, which comes to 47 degrees. And we can apply the same logic to the angle on the other side, which is angle PEO. That's the angle marked in orange. Since angle AEO as a whole is 90 degrees and a part of it, angle AEP, is 36, the remaining part, angle PEO, should be equal to 90 degrees minus 36 degrees, which comes to 54 degrees. So now we consider the angle that we have been asked to find out, the one in question mark, and let that angle be x. Now, if I consider the bigger arc DE, so it's the part of the arc that's opposite to P, right? So we're considering the bigger arc DE, not the smaller arc DPE, but the arc on the other side, which is the bigger arc DE. So this bigger arc DE subtends an angle DPE, which we have assumed to be x, at the circumference, right? And the same arc, the bigger arc DE, subtends this angle, the angle marked in red, at the center O of the circle. Now note that this is not an usual angle. This is what's called a reflex angle, meaning that it's greater than 180 degrees, because we are considering the bigger arc, the arc DE, which is bigger than half of the circle, right? So that's why the angle subtended by that particular arc at the center will be a reflex angle. And we also know that the angle subtended by the arc of a circle at the center is 2 times the angle subtended by the same arc at the circumference. And in this case, the bigger arc DE subtends an angle x at the circumference. So that makes this reflex angle that we have indicated in red as equal to 2 times x. And if this is 2x, then this angle within the quadrilateral PDOE, so that's the angle that I have marked in pink or magenta. So that angle will be equal to 360 minus 2x, because the sum of the angles around a point, in this case it's the center O, so sum of the angles around the center O should be 360. We know that the reflex angle DOE is 2x, so that makes the other angle as 360 minus 2x. Now consider the quadrilateral PDOE. So sum of the angles within this quadrilateral should be equal to 360. So we can write x plus 360 minus 2x. So these are the two angles. And the other two angles are 47 and 54. So they should all add up to 360. And once we have this equation, it becomes very, very easy to solve for x, and x comes as 101 degrees. So the correct answer in this case will be the value of angle QPR is 101 degrees.